very quick review about what we talked about it last time, was that in all the axial load, torsion, bending, and the shear, we come up with two types of stress. It's either normal stress or shear stress. Two types of stress. And then it says what we calculate in either of these four loading is going to be either parallel to the x or parallel to the y-axis. All we have. And they said, so we don't know. There are two cases that we don't know what's going to be the stress in any other angle, first of all. And the second is that if we calculate it along the x or y, it's not necessarily the maximum along the x or y. The maximum might happen along any other axis. So two things we are looking for. What if we are asking, okay, what's the stress along the 30 degrees angle? How we calculate that? And the second was that where the maximum normal and shear stress happens, so we can design the element for that angle or for that stress. And we went through the formula, how to do that with the formula. There is another method that is called the Mohr circle. And this Mohr circle, you are going to have it in many courses after that. And basically what we did last time, but just by some trigonometric way rather than using the formula. So basically like that. If you are given the stress, you can calculate the stress at any given angle, or you can calculate the maximum and minimum without using any of those formulas we did it last time. And I suggest that try to learn that, because this is one of the things that you're gonna reuse it in many courses later on when you take. So when you want to do for the Mohr circle, the Mohr circle comes with some kind of convention that says, okay, the very first thing is that, let's say we have the element like this. And that element has sigma x, sigma y, and tau xy, sigma xy. So this is what we have, and this is going to be our x-axis, and this is going to be our y-axis for that element. There are some conventions, before I tell you, okay, how I'm going to make a circle and how I'm going to calculate everything, there's some convention that I need to remember. So it's called the Mohr convention or Mohr circle convention. So the first one is the one that we are familiar with. What was the sigma if it is in tensile? For tensile stress, sigma considered positive, correct? So if it's tensile, it's positive. For compression stress, sigma considered negative. We had these two before. So if the tensile stress is positive, if the compression stress is negative. What about those tau? So I have a tau. How I'm going to consider those tau positive or negative? So this is the convention. It's not some anything you do. They just come with that. I just said okay. If the tau on the face, rotate that face. Forget about. So assume there's only that tau on the face. If that tau rotate that element clockwise, it's considered positive. If the tau on the face rotated counterclockwise, it's considered negative. So here, if tau on the face rotates that face clockwise, then we consider the tau positive. If tau on the face rotates that face counterclockwise, then the tau is negative. So for example, here, if I want to look at it and just give example, if I have an element, I'm just going to look at one. So if I have an element and the tau on the face going down, so that tau is rotating the element which direction? Clockwise. So the tau is going to be positive there. Here, example again. If I have the same face and now the tau is going upward, this time the tau wants to rotate it counterclockwise, so it's going to be negative. As I said, this is just convention. There's nothing about it. Now, again, now I'm going to look at this element. So, I'm going to write the stress along the x-axis and stress along the y-axis for that given element. So, for each element, we can write that. So, for the element, for any element we are given. So, write x and y data point for the element. X, the data point is going to be the data point in form of x and tau. For the x here, the sigma on the x, is it positive or negative? Sigma x here. So it's going to be positive, right? So the data point along the x is the positive sigma x. What about the tau? Is it positive or negative? The tau on the x-axis, the tau on here. It's counterclockwise, so it's going to be negative. So it's going to be negative tau xy. The data point, the second data point I'm going to write it, I'm writing it for the y-axis. Again, sigma y around the y-axis, is it positive or negative? Let's see, is sigma x. For this case, it's positive. Again, so it's going to be positive sigma y. What about the tau? The tau on the y is rotating it counterclockwise, so it's going to be positive. So it's going to be positive here. Now I have two data points. So, okay, so I have two data points. I'm gonna plot those two data points on the x and y axis, where the x is sigma and y is tau. So I'm going to make a coordinate system that is made of sigma and the stress. So it's going to be tau going to be tau, and it's going to be sigma. This is my coordinate system. I'm going to first find these 2 points. So the next is that locate x and y on sigma tau coordinate. So I'm going to locate those. Again, this is for this element that I draw. I just draw everything positive there. When you are given, they might not be positive and there might be something else. But for here, where would be the x and where would be the y? So x is the sigma x and negative tau x, and y is the sigma y as plus tau. Let me make tau where it's make sure I'm writing it correctly. So I'm going to locate them. Assume here sigma s is larger than the sigma y. Just assume. Okay. So the x is going to be, assume the x is going to be somewhere here, because it's the x is plus sigma x and minus tau xy. Okay, and the y is, assume it's the y, which is plus sigma y and plus tau xy. I'm going to write it later on. Now that I have these x and y, so I have these 2 points. So draw a circle that passes through X and Y. So assume X and Y are 2 points on a circle. I'm gonna draw a circle that pass through them. So this part is a little bit tricky. So I draw a circle that passes through those 2 points. So now I'm gonna put right here. Now it's gonna be my y plus sigma x and plus tau xy. So I have 2 points. I draw a circle pass through it. You got it up to here? Now from this point I can start to calculate everything I want for whatever I need. So the very first thing that I want to find out is where is going to be my center. If I connect these 2 points together, this is going to be my center, correct? So if this is the center, what's the distance? What's the location of the center? This distance, how much is this distance? The center. Is the average of sigma x and sigma y. Correct? Average of sigma x and sigma y would be that point. So I can go and say this is the sigma average would be the sigma x plus sigma y divided by 2. So that's where my center is located. If this is a point A, what's the coordinate for the point A? What's the coordinate for point A?
X 0.
Y is 0. Sigma max and 0. So the coordinate at the edge is going to be sigma max and 0. What's the coordinate for the B?
Sigma min.
Sigma min and 0. What about the D on the top and E on the bottom? So if I go ahead and draw. What's the coordinate for here for the D?
Tau max and
Sigma.
sigma average plus sigma min.
Sigma average. That's going to be sigma average and tau max. What about this point here if I call it E? Sigma average and
Tau min.
so remember the tau, the magnitude of tau min is negative of tau max. Because it's just the same, it's just going to be negative of tau max. So it's going to be tau max, negative of tau max. If I drop from here down and from here up, what is this distance? I'm gonna get it from trigonometry.
Sigma x minus sigma average.
Sorry, that's sigma y. Yes, sigma y. What would be
Sigma x minus sigma average.
sigma x minus sigma average? So if I do that, what I would get? It's easier than that. This is sigma x, correct? This is sigma y. Agree? If I add them and divide it by 2 gives me the distance to the center. If I sigma x minus sigma y, what would be? From here to here, correct? Sigma x, sigma y. Sigma x minus sigma y is this distance. This is half of it. So sigma x minus sigma y divided by 2. Or we can do it that way, because this way is easier. So this distance is going to be sigma x minus sigma y divided by 2. This would be R. And look at here. What was the angle from X to A? From last time. This angle from X to A was 2 theta p, correct? The angle that you get the maximum, so it's going to be 2 theta p, or is it where you get the maximum stress or the principal axis. So that's going to be 2 theta p. I think that's all of them. Is a question about. So as long as I have that circle, I don't need to know any equation. I can do trigonometry and some sine cosine equation and calculate whatever I want from that circle. So for example, the sigma max, how much the sigma max? Sigma average plus R. The sigma mean, sigma average minus R. The tau max is just the R. The tau mean is negative of the R. That angle here is just the tangent inverse of this over that. Sigma x divided by that. So anything I'm asking, I just can use that and find. I don't need to know any equation for that purpose. So a couple of points. A and B are principal planes. So A and B are principal planes. So that's where you get the maximum and minimum stress there. So you get the sigma max and sigma min there. D and E are the axes when you get, or are the plane that you get the maximum shear stress. D and E planes for maximum shearing stress. The next is on the Mohr diagram. Circle. Angles are 2 times of the real. So if the angle on the Mohr diagram is 60 degrees, it means that it is 30. If the angles on Mohr diagram is 180, means that in reality it is 90. So the real one is half of that in that case. The next thing is that, what's the angle between the A and D? What do you use to show the angle? No. If one said it is, for example, it is, I want right here, XCA. So how I'm going to say the XCA or ACD? Okay. Sometimes I say that.
I think back in the day it was like one of these and then XCA.
Like this.
Yeah.
So if the angle XCA, so, or let's do it for the ACD first, and then XCA. The angle for ACD, how much the angle for the ACD? ACD, 90 degrees. So what does it mean? It means that the sigma x and sigma max and tau max, sigma max and tau max are how much apart? Sigma and tau max planes are 45 degrees apart. Well, basically 90 divided by 2. If on that Mohr circle they are 90 degrees apart, it means that in reality they are 45 degrees apart in reality. So sigma max and tau max planes are 45 degrees apart in real. Look at the angle XCA. What's the angle XCA? It's 2 theta p. So whatever is the angle x, assume the angle XCA here is 30 degrees. Assume. So it means that on the real element, if I rotate 15 degrees, I go from where I am to the maximum angle. Now, which direction should I rotate? Remember that theta P rotates from Cx toward the Ca. So theta P rotates from Cx to Ca. So this is Cx and it's rotated to the Ca. In this case here it's rotate clockwise or counterclockwise. So here it rotates counterclockwise, so in the real element you have to rotate also counterclockwise. So here TP rotates counterclockwise. Therefore, in real element, theta P should rotate counterclockwise as well. So however you rotate here, you rotate the same way in the real element. So for example here from the A to D, I rotate 90 degrees counterclockwise, so in the reality from A to D I have to rotate 45 degrees counterclockwise. Any question about any of the, so these are the basics of the Mohr circle. I'm gonna put it on the example so you can see how we use it, but about the basics of that, any question? So the example, we did it for, and using the formula, this time we are gonna do it using the Mohr circle. So if I go ahead and say, okay, this is my, I have an element like this. And it was 50 this way for the shear. 50, and we have 10 this way. For what we had. It's going to be our x. That's going to be our y. So, the very first point I have to do, the very first thing I need to do is just I go ahead and I have to establish the x and y points. So, x and y. So, what's the coordinate for the x? Because that's the most important part of it. The rest is just trigonometry. So, what's the coordinate for the x?
Plus 50.
So, the normal stress is tensile, so it's a tension, so it's going to be plus 50. What about the tau?
Minus 40.
minus 40 because it's counterclockwise. Now in the y-axis, how much is the normal stress?
Minus 10
Minus 10. And the tau?
plus 40.
Plus 40. That's the entire thing. If I have these 2 points, the rest is the trigonometry. So now I'm going to draw that coordinate system and put that x and y on top of that. So I'm going to draw. So that's going to be my coordinate system. So it's going to be tau and sigma. Now I'm going to find out those 2 points. So it's gonna 50 and 10 and 40, so I'm gonna do 1, 2, 3, 5, 1, 2, 3. So 50 and negative 40, so 10, 20, 30, 40, 50, and negative 40, so it's gonna come out somewhere here. So that's the x. 50 and negative 40. And the y is negative 10 and 40. So negative 10 and 40 is going to be here. Then I'm going to draw a circle through that. Then it's going to be, that's going to be my center here. So I want to know the sigma max and sigma min. So how much the sigma max is the sigma average plus R. Okay, so I have to go and find the sigma average. How much is the sigma average? How much is this distance? It's 20, correct? So sigma average, that distance is 20. How much the R? So what's this distance? So I know that this is 50. Let me put that. That is 50. And this is minus 10. That's going to be how much?
30.
It's going to be 30. However you calculate it, so it's 30, correct? If this is 0 and it's 20 and it's 50, so that should be 30. How much the height to the point of the x? How much is that height? 40. So if this is the r, how much is the r? 50. How do you calculate it? The r is?
R is equal to
40 squared, 30 squared, the square root of that, correct? In that triangle, so it's going to be 30 squared plus 40 squared, square root of that, which would be 50. So that's the r. Now, what I want is that what's the sigma max, what's the sigma mean, where it happens, what's the tau max, what's the tau mean, where it's happening. So I started with the sigma max. How much is, what's the sigma max?
50?
Nope.
Oh, wait, no, that's not.
Sigma max is here. That's the sigma max.
Yep.
So sigma max is equal to what? If I want to find it from that here. If this is, this point is the
Oh, yep, so it'd be 70 degrees.
x of the c. Sigma max is a sigma average
Plus
plus r, correct?
R. 70.
So sigma max is the xc plus r, or basically the sigma average plus r, which would be 20 plus 50 would be 70. Sigma mean, how much is the sigma mean? The sigma mean is sitting here. Is the xc minus r for sigma average. So is xc minus r, or sigma average minus r, which is going to be 20 minus 50, it's going to be negative 30. Now, the 2 theta p, where's the 2 theta p? From the x to sigma max, correct? So it's going to be 2 theta p. So I'm going to calculate the 2 theta p. What's the tangent 2 theta p? How is the tangent 2 theta p? 40 over 30. 40 over 30. Therefore, the theta p is, if you calculate it,
1.333333.
radian, yeah? Almost in the degree. Yes, that's 26.6.
Yeah.
So 20.26.6 degrees. But maybe make it a little bit better to understand it. If I make that point C, that's here, assume it's a point C, and that's the point A. That's sorry, O.
Would you take it?
So it's going to be OC, probably it's easier to see that. OC plus R. Okay, now if I look at that, it means that the Cx going to the so from the Cx to Ca, how is rotating? This is point A and this is point B. The Cx rotates 26, rotates counterclockwise. To reach Ca. Correct? therefore the element should rotate 26.6 degrees counterclockwise to reach sigma max plane. So if I want to draw where's the sigma max plane, it's gonna look like this. Look like that. And if I put the number, the sigma max here, that's the sigma max. So 70. And the sigma mean is 30, so it's going to be -30. How much the tau in this case? Tau is 0. Sigma max and sigma mean, there's no tau. Tau is 0. And how much is it is rotated? It's rotated counterclockwise 26.6 degrees. -30. So you got what happened there? So any question how I find the sigma max, sigma mean, and its location? Without using any formula. Now I want to find out what's the tau max and its location. Now, I want to find the tau max and tau mean. Where the tau max and tau mean happens? Happen happens at the very top and at the very bottom. So it happens here. So that's it happens here. It's going to call the point D and the point E. And so if I come here, that's the negative tau max. If I come here, that's the positive tau max. So that point is here, positive tau max. So, if I want to use that, how much the tau max? 50. Before 50. Tau to
R.
R, so the radius. So tau max is the R, and it is, as you said, 50. So that's how I'm going to find the tau max. Now, where the tau max happen? What's the location of the tau max?
Sigma average.
No, it happened, yeah, the sigma for the tau max sigma average, but what's the angle that it happens there?
Um, 2 theta plus 90.
First of all, what's the theta s or 2 theta s? Remember that 2 theta p is from where I am to maximum sigma. 2 theta s was from where I am to
Maximum tau.
maximum tau. So the 2 theta s is gonna be which? Make that bigger deal a little bit. It's going from here to here. That is the 2 theta s. Correct? Now, here, what's the relationship between the 2 theta s and 2 theta p?
2 theta s is 2 theta p plus 90.
Yeah. So 2 theta s. So here, 2 theta s is 2 theta p plus 90. Therefore, theta s is theta p plus 45 degrees. So it says that basically there are 45 degrees here. Remember that we already said that theta s and theta p is already 45 degrees apart. So theta s, so how much would be the theta s? Remember that this equation, I write it from this element. What if the element is going to be different, the equation might be something else, correct? So theta s would be 26.6 plus 45, which would be, how much is that?
71.6.
7, how much?
71.6.
71.6 degrees. Which way?
Counterclockwise.
Counterclockwise. So it is rotate counterclockwise, so it should be,
Negative.
no, counterclockwise. No, I want to know, is it clockwise or counterclockwise, because I want to know which way I have to rotate my element. So now if I want to draw that element, so here's the 26 degrees. This is 26 degrees rotated. Look at here. I want to make sure. So it's here and I rotated 26 degrees. And now I want to go to 71. So it's gonna look like this. So from here goes like this. So my element would look like this. And then so what would the sigma when I have the tau max and tau min?
Sigma average.
Sigma average. As is gonna be 20. So it's gonna be sigma average on all faces. So sigma average of 20. Now, what about the top? How would be the direction of the top? So my x was here, now it is here. So that's my x prime, correct? That's x, I went to the x prime, which is gonna be, so from here I rotated to that point. So tau at that point is positive or negative? So if it is positive, it should be
Clockwise.
clockwise. So as soon as you have one of them, you can get the other three. So tau would be the tau max, which would be how much was the tau max?
50.
So again, I'm going to just put, so at D, tau at D is positive, correct? So at D, tau is positive. Therefore, tau on that face should rotate. Tau on that face should rotate the face clockwise. Just in case later on you wonder why we put it that way. So this is the basics of the Mohr circle. So you just draw it and use some trigonometry to find out what you need to find out. As I said, no form, you don't need to memorize or know any formula. This method, as I said, in other courses that you're going to have, you're going to use this method for different purposes, for the design or calculation or analysis. Any questions? So next I'm going to talk about two specific cases. So this is the general cases. Next I will discuss the two specific cases, how the Mohr circle would look like for those particular cases. So the explanation and the example is for general cases. What if I have only axial load? So the very first chapter, if I have only axial load on my elements, there is no moment, there's no torsion, there's no bending. What would the Mohr circle for that case look like? So basically, the Mohr circle for axial load. If I only have an axial load. So assume I have an element, look like this. And there's an axial load or axial force applied on that, on both ends of that. Nothing on the x-axis, nothing else happening there. And it's going to be my x and y axis. So that's the x, and that's the y. If I go ahead and draw an element inside that, if I draw an element inside that, what stresses I would have on that element?
You have tension and then also compression from the top and bottom.
I have sigma x, that's right. On the y-axis, there's no force along the y-axis, so no tension along the y-axis. If it's just the axial load, do I have the shear? There's no shear. So that's the only thing I'm gonna have on my element, correct? Now what if I'm gonna rotate that element? So if I have the same things, I'm gonna rotate it 45 degrees. Let's see what happened. On that axis. So if I rotate that 45 degrees, I want to see what happened on that. Okay. Let's go and draw this Mohr circle for that. If this is my case, what's the x and y point? How much the x? How much the y?
Y is 0, F, and then X is just F.
It's the F divided by area, so it's basically the sigma x. Correct? So this is plus sigma x and 0. And the y would be 0 and 0, correct? Now if I go ahead and draw that, I'll go ahead and say I want to draw those 2 points. So that's the tau, that's the sigma. So the first point would be, where would be the x? Somewhere here, correct? So that's the x, which is sigma x and 0. Where would be the y?
That's 0, 0.
It's gonna be right here. Correct. So the y would be as 0 and 0. Now if I go ahead and draw a circle through that, that's gonna be my circle, correct? And then at the center I have that's the sigma average. So that's again my point A, my point B, that's the center, that's the E, that's the D, which is the plus tau and sigma average, and that's the, if I come down here, it's going to be the E, which is negative tau max and sigma average. What's the positive tau max and sigma average? How much the 2 theta s? That's the 2 theta s. Going from the sigma max to tau max. And how much is this distance? Sigma x is f divided by, there we go. How much is this distance? Tau max is equal to r. Now come back here. If I rotate that 45 degrees, what would happen?
You're not going to have shear force as well.
So if I rotate it 45 degrees here, it means that I have to go from X to D. I rotate 90 degrees. 45 degrees there means 90 degrees here. If I rotate 90 degrees, the sigma would be sigma average on all faces, correct? So it's going to be sigma average on all faces, so I would have the sigma average on all faces. And what about the tau? So tau here, in this face, is it going to work clockwise or counterclockwise? Here. So it's going this way or this way? So this is my face. This is sigma. It's rotate to sigma max. This is sigma, rotate to sigma max. The tau is positive. So it's going to be clockwise. So it's going to be that way. So, and then you have the rest of that. So, okay, at D, tau is positive, therefore rotates clockwise. Therefore tau rotates so I can remember at the very first chapter we talked about it that says that there's a 45 degrees between the maximum normal stress and shear stress if we have only axial load. Remember the very first chapter we talked about the axial load. It says that wherever we have the maximum shear stress, if we rotate it 45 degrees, it's going to be maximum shear, and that's why. So any question? So this is the case that I only have the normal stress. Now I want to look at another case that I only have originally. I only have shear stress. So I want to draw the Mohr circle for torsion. Again, if I have an element, so this time I have an element under the, so let's assume I have an element like that. And then I have the torsion that element. And then it's going to get the same x and y axis. And then if I have the element sitting there, along parallel to x and y, if it's under the torsion, I'm gonna only have shear stress on that. There's not gonna be any so when the sigma x equal to sigma, what's the sigma x there? 0, correct? What's the sigma y? 0. When the sigma x and sigma y are equal, what does it mean? When the sigma x and sigma y are equal, it means that tau should be
At its max.
at its max. If I have 2 points that are their sigma are equal, the only point that their sigma is equal is where I have the tau max. So here I don't have any normal, so that should be tau max. And now if I want to see if I rotate that 45 degrees, what would happen? So I'm going to have the same again. I'm going to draw it first. So remember here, we are here, theta is 45 degrees, the same there, the theta is 45 degrees. So if I rotate that 45 degrees, I want to see what happens. So before I do that again, I will go ahead and draw a more circle for this one. So if I want to draw more circle, I'm going to draw the x and y. So what's the x and y?
0, 0.
And the top
Max.
and
Negative max.
negative. This guy was tau max and negative tau max. So if I go ahead and draw the Mohr circle, so where would be the x and y? This is sigma, and that's the tau. So, for the x, is it positive or negative? Is it positive sigma max or negative sigma max for the x?
Positive. Wait, no.
You rotate counterclockwise, so it's gonna be negative there. And positive there. So the x would be located somewhere here. That's the x, which is 0 and negative tau max. And then the y would be somewhere here, which is 0 and positive tau max. Now if I go ahead and draw a circle through those 2 points, so that's going to be the A, as we had before, which was the, what was the coordinate for the A? Sigma max and 0, correct? Coordinate for the B?
Sigma min.
Sigma mean and 0. How, what's the 2 theta P? Oh, sorry, 2 theta S?
90.
Okay, it's going from where to where?
Can it be? Would it be 0? Yeah, that makes more sense actually. Now I think about it.
Theta is 0, so it means that
Because we're already at
the
tau.
2 theta S is, so the theta S is basically there, so 2 theta is 0, so theta is 0, so at 0 you have the tau
Max.
max. The 2 theta P is this, so from the point X going to there, so it's going to be 90 degrees, so it's going to be here, from here to here it's going to be 2 theta P. Now, if I rotate 45 degrees from where I am, so I'm here and I rotate, so I'm here, that's my X, correct? The X is there. And I rotate 45 degrees, I get to the point A. What happened at the point A?
Sigma is now max.
Sigma now is max, so then there, so this is my face, now it is there. So it is 0, now it's there, so it's gonna be sigma max. So it's gonna be sigma max there. What about the other face? Sigma mean. So it becomes the sigma mean. How much is the tau?
The taus would now become 0.
The tau now becomes 0. So here, in this case, the tau is 0. So again here, how much the sigma average? It's going to be 0. The sigma max and sigma mean for this case, so sigma average is 0. Sigma max is just R, which is going to be plus tau max. Sigma mean is negative R, which is negative tau max. we originally were, that's where was the x and y, and then we rotated to x prime and y prime. Just in case. And that is the theta. So any question about these two cases? So these are the, what if originally we have only the stress, what if we originally we have only the normal stress or shear stress? Again, you see that if you have the maximum shear stress at whatever angle, if I rotate 45 degrees, I get to maximum normal stress. So wherever the one of them is maximum, 45 degrees apart is the other one become max. So if the normal stress is max, 45 degrees apart is shear max or vice versa.
When we were talking about shear stress earlier, you mentioned how there basically has to be normal stress when you're shearing something because like when it shears, it pushes it sideways almost. Does that not apply in this situation, or is that only applied in certain situations, like once it actually starts breaking, that's when it
The one that you're talking about, the normal, is the lateral force. When you have the lateral force, this is gonna cause also the stress. So if I have it here, assume instead I have a force, lateral force, it might cut it that way. Eventually, these two cases are very ideal cases, never happen or something like that. In reality, you are gonna have the combination of all those four loading, the shear, the axial, the bending, and the moment, and then you have to add them together to see what you get. Example in the remaining time. So two examples, probably we're not gonna have many problems on that. Just do one of them. Again, you don't need to memorize or confuse yourself with these things. If you know the general case, how the general case works, these are the special case for the general case. So let's look at an example. It says that if we have an element like this, and then there's 100. I don't put the unit says a megapascal because they're not interested in that one. So 100, 160. And then there's a 48. Like that. So it wants to know what the sigma means, sigma max. P. The stress complex. So first it wants to know the sigma mean, sigma max. So sigma mean, sigma max, and theta P. The second was that if theta is 30, then how much is there? So what's the sigma and tau? This is what it's asking for. So the very first part again is starting with x and y. So how much is the x and y? So for the x, tensile, so it's positive 100, correct? So it's positive 100. About the shear, positive or negative?
Positive 48.
Positive 48, because it is rotating it clockwise. So it's positive 48. What about the y?
Positive 60.
Positive 60.
Negative 48.
And negative 48. So that's the x and y. So that will be the x and y axis there. That is the x. That is the y axis. Now I have to go ahead and make here more circle. So it's 100, 160, and so if I draw it like this, there's the tau, sigma, so the first point is 100 and plus 48, so it's going to be, and it's going to be somewhere there. So that's my first point. And the second point is 60 and negative 48, so it's going to be somewhere there. So those are the 2 points that I have, and then I'm going to make a circle through them. But that's it. Make a circle through them, and then I want to find the center and the other 2 points. So I go ahead and say there's the center. There's the center there. Point A, that's my point B, so that's a sigma max, sigma mean, so the very first part of that is what's the sigma max and sigma mean and theta P. So let's find some of those information that you want. The sigma average of the center is how much the sigma average is 100, because this is 100, correct? And this is 60. 60, so it's gonna 100 plus 60 divided by 2, so it's gonna be
80.
80. So 100 plus 60 divided by 2, which is gonna be 80. That's what we have. Then how much is this? It's 100 minus 80, so it's gonna be 20, correct? This is 100 minus 80, that's gonna 20. So, now I want to find the R. So if I consider that as an R, so this is the R. And this is 48. So how much is the R? Is 48 squared in this triangle plus 20 squared square root of, so in this triangle I have the height, I have the width. So if I do that, the R should come up at 52, correct? So it's going to be 52. Now that I have the R, what would be sigma max? Sigma average plus R, which is going to be 80 plus 52. So
Yeah, I did the math.
it comes out as 132. And the sigma mean, sigma average minus R, correct? It's going to be 80 minus 52, which becomes 28. Got that? Now, what's the location of that? So look at here, in this case, the theta p, the 2 theta p is like that. So it's a 2 theta p. It's going to be clockwise. So from the point X, remember that's the point X, that's the point Y. So from point X, I come to the sigma max. So I have to rotate this much clockwise. So the tangent to theta p is how much? It's 48 divided by 20, correct?
Yep.
So the theta p would be
33.69.
so 33.7.
Yeah.
Which direction?
Clockwise.
So that much and clockwise. So I have to rotate that much clockwise to get to that point. So if I want to draw it, it's gonna look like this. So it's gonna be sigma max 132. That's sigma max. That's gonna be sigma mean 28. Sigma mean. The tau is 0 in that case, and the angle that I have is that I rotate it, theta p equal to 33.7. So I rotate it, counter, I rotate it clockwise. Got it? Now the next part is that, let's see, just give you some idea how to do it. What if I rotate to 30 degrees? So it means that wherever I am wherever is the point X, I'm gonna rotate how much on the circle?
30 degrees.
No.
Um, 60.
We're gonna 60, 2 times of that. So I'm gonna rotate 60 degrees from there to get to the X prime. So basically, I don't know where it's gonna be, but assume, so 2 theta is 60 degrees. So assume if I rotate 2 theta and 60 degrees, so if I go there 60 degrees, assume I get to the X prime at that point. And then if I draw that through the center, so that's the X prime, that's the Y prime. So I rotate 60 degrees to get to that angle. And then here, what would be this? What is this? X prime, Y prime. And this one is the sigma X prime. And this one would be sigma Y prime. So if I want to do that, if I go ahead and say, okay, that's the phi, this angle here, if I assume this angle is going to be phi, how much is the phi? The phi is 180 minus 2 times of 2 times of 33.7 minus 2 times of 30, which becomes 52.6. So now if I have the phi, what would be the sigma X prime? Sigma X prime. If I have the top, is the sigma mean, is the R, correct?
Looking for sigma X prime right now.
No, the formula for that. If I get the sigma average minus this, so the sigma average minus R cosine phi, correct? R cosine phi is this one. So I can say that the sigma X prime is the sigma average minus R cosine phi. It's going to be 80 minus 52 cosine 52.6. The sigma Y prime, sigma average, plus, now look at it, it's a sigma average plus this. What's this angle? What's this length again? It's the same as the length there. So it's going to be the same. Sigma Y prime. So this length and this length are the same. So this angle is the same. So it's the R cosine phi. This is the R cosine phi. So it's going to be 80 plus 52 cosine 52.6. And so that's the sigma, and tau x prime y prime. How much is the tau x prime y prime? This is the tau x prime y prime, correct? How much is that? R sine phi, correct? So it's going to be R sine phi. And so it's going to be 52 sine 52.6. So from 48.4. So these are the values that we have. I'm gonna just draw them very quickly. If I draw the element this time is gonna look like this. So you just have to show them on the, so on the x prime, sigma x prime is 48.4. On the y prime, you have sigma y prime 1116. And the tau you're going to get like this, because the positive, so it's rotate clockwise, so it's going to be tau x prime y prime. 41.3. And how much is it rotated? From the x 30 degrees, correct? Basically it's rotated 30 degrees. So if you look at it, I know sometimes, for example, in this one, the trigonometry part might be a little bit confusing, but it's just, as long as you get the sine and cosine correct, everything would be fine. And remember that it's x prime, y prime is positive, so it rotates clockwise. So any question?